In this video, we will discuss one of the most famous deep learning library which was developed by Google, the TensorFlow. And this is the same library that we will be using for our coding activities for this course. Deep learning is a complex discipline, but implementing deep learning models is far less daunting and difficult than it used to be, and this is all thanks to such libraries like the Google's TensorFlow. Now, Google's TensorFlow was created by the Google Brain team, and it is an open source library which was first made public in the late 2015, whereas the first stable version appeared around 2017. Now, TensorFlow architecture works in three parts. The first one, pre-processing the data. Second one, building the model. And third one, training and estimation of the model performance. Now, this is called TensorFlow because it takes input as a multi-dimensional array, also known as tensors. You can construct a sort of flowchart of operation, or what we call as graph, that you want to perform on that particular input. The input goes in at one end, and then it flows through this system of multiple operations and come out the other end as output. And this is why we call the framework as TensorFlow, because the tensor goes in, flows through a list of operations, and then it comes out on the other side as output. Now, these models, the models that we implement using TensorFlow, can be trained and used on both GPU as well as CPUs. Now, we know GPUs were initially designed for video games, and it was in late 2010 when some of the Stanford researchers found that GPU was also very good at performing matrix operation and algebra. And this makes them very fast in doing the kind of calculations which are important for deep neural network. As we know, deep learning relies a lot on such matrix multiplication. Also, another significant feature of TensorFlow is the tensor board. The tensor board enables to monitor graphically and visually what a TensorFlow is doing. In the course of this course, I will also be introducing you to tensor board, and we will check into some of the examples of using tensor board. Now, to summarize, there are two components of TensorFlow. The first one, tensor, and second one, the graphs or the computational graphs. As we have discussed, the TensorFlow's name is directly derived from its core framework, the tensor. and the tensor is one of the important components of a TensorFlow framework. In TensorFlow, all the components involved are tensors. A tensor is nothing but a matrix of n dimension that represents data. All the values in a particular tensor hold identical data types, which is known as shape. The shape of the data is also sometimes referred to as its dimensionality. A tensor can be originated from the input data, or it can be a result of a computation. So a tensor is nothing but an n-dimensional array. For example, a 1 cross 1 tensor is a scalar, and 1 cross n tensor is nothing but what we call as vectors. An n cross n tensor is a matrix, and an n cross n cross n tensor is of course a three-dimensional array. And this of course generalizes for any dimension. So this picture correctly captures the differences between each. The first figure is a scalar, second figure is a vector, third one is a matrix, and finally the fourth one is a three-dimensional array, or we can call it as a 3 cross 1 cross 2 array. So 3 cross 1 cross 2 means 3 matrices of the size 1 cross 2. I think I made a small mistake. So in this example, it is a 4 cross 1 cross 2 tensor, or it is a three-dimensional array. It is a 4 cross 1 cross 2. That means 4 matrices. So we can see here 4 matrices of size 1 cross 2, that is 1 row and 2 columns. While typically all of these above constructs are valid tensors, but normally when we speak of tensors, we are generally speaking of the generalization of the concept of a matrix of n greater than or equal to 3 dimensions. So we will normally refer only to tensors of 3 dimensions or more as a tensor in order to avoid confusion. Now, a quick refresher for those who have forgotten the concept of arrays, shape and dimension. This is a beautiful example which captures and refresh your memories. For example, the first figure is a one-dimensional array. So there is only one axis, which is axis 0, and when you look the shape, it will give you 4 comma. So that means it is a one-dimensional array. Or basically we could say it is a vector, right? Now for a two-dimensional array, we have axis 0 and axis 1, and if we check its shape, it would be 2, 3, that is 2 rows and 3 columns. And if we check its dimension, it will give you the dimension to be 2. Similarly, this is an example of a three-dimensional array. So this is my axis 0, axis 1 and axis 2. So shape is 4, 3, 2. So 4 because 1, 2, 3 and 4, and this 3 because in axis 1 we have 1, 2, 3 columns, and 2 here because in axis 2 I have one column this and the other column here. So it is 4, 3, 2, and of course the dimension is 3. Again, a quick refresher as how to construct a multi-dimensional array. So you might have guessed at this point that this is a three-dimensional array and it is a 3 cross 3 cross 3 tensor. Now why it is a 3 cross 3 tensor is that here you could see you have 3 matrices. So this is my first matrix, the second one and the third matrix, and you have 3 matrices of size 3 cross 3. That means if you take the first matrix, you have 3 rows. So these are my 3 rows, and you have 3 columns, right? So that is how it becomes a 3 cross 3 cross 3 tensor. That is, it has 3 matrices of size 3 cross 3, that is 3 rows and 3 columns. So when you print that, it appears to be of course like this, and it says its rank is 3 or its dimension is 3. Now there are many ways wherein which you might want to visualize a tensor with more than 2 axes. So this is an example of a 3-axis tensor, or 3-axis tensor means it is a 3D tensor, or it is a 3-dimensional array which has a shape 3, 2, 5. So according to your convenience, whenever you are given such a shape, it is up to you as how you wanted to visualize those images in your mind, right? So you can either picturize that to be something like in figure 1, or if it is easy for you to picturize it in a way as in figure 2, or you could picturize it as in figure 3. So this is a 3-dimensional tensor or a 3D tensor or a 3-dimensional array of shape 3, 2, 5. Why 3? Because you have 3 blocks or 3 matrices which are shown in 3 different colors. Then you have, if you take one particular matrix, you have for each of that matrix 2 rows, and of course you have 5 columns. Now let us consider a tensor of rank 4 or dimension 4 and shape 3, 2, 4, 5. So here you can see if it is a 3-dimensional tensor, 3D tensor, or if it has a rank 4, whatever way you wanted to say it, you will have 4 axes. That is why you have 1, 2, 3 and 4. Right? So it has a rank 4. This is axis 0. 5 is axis -1. Now let's see how we visualize this. So this is how you can picturize this particular tensor of shape 3, 2, 4, 5. 3 because you have 3 blocks, so each of them is indicated by 3 different colors, right? And if you take one particular block, suppose you take this orange block, you have 2 rows. This is your first row, this is your second row. And you have 4 columns, the first column, second, third and fourth. And you have a depth of 5, right? So that is 1, this is 1, 2, 3, 4, 5, right? So depth of 5, 1, 2, 3, 4, 5. So that is how this 5 comes. So if you ask to print the number of dimension, it shows 4. The shape of the tensor by tensor.shape is the command. It will give you 3, 2, 4, 5 of course. Element along axis 0 of tensor is 3. Element along the last axis is 5. And the total number of elements that can be accommodated in this tensor is nothing but 3 into 2 into 4 into 5, which is 120. As discussed in the beginning of this video, the second important component of a TensorFlow is graph. In TensorFlow, all the operations are conducted inside a graph. And a graph is a set of computations that takes place successively. The graph outlines the operations and the connections between the nodes. The edges of these nodes are the tensors, and the nodes itself are the operations. Now, TensorFlow allows us to implement machine learning and deep learning algorithms by creating and computing operations that interact with one another. These interactions form what we call as computational graph, with which we can intuitively represent complicated functional architectures. Now, for those people who are new to this concept of graph, a graph is nothing but a set of interconnected entities commonly called as nodes or vertices. And these nodes are connected to each other through edges. In TensorFlow, each of the graph's node represents an operation, possibly applied to some input, and can generate an output that can be passed to another node. Now, suppose you have an expression A is equal to B plus C into C plus 2. Now, this expression can be broken down into the following component. Say D is equal to B plus C, E is equal to C plus 2, and finally A is equal to D into E. And we can represent these operations as a simple computational graph as something like this. So as you can see, this is what is called as a node. So a node represents an operation. And B and C are nothing but the input. So we can call it a variable or a value or a tensor, right? So we have B and C, and in this node I compute B plus C and assign it to D. Similarly, in this node I compute C plus 2 and assign it into E, and finally to my parent node, my root node, I compute D into E and assign it to A. Now, this might seem to be a very silly example, but notice a powerful idea in expressing this equation into three such components or as a computational graph. As you can see from the computational graph, 2 of the computation, which is D is equal to B plus C and E is equal to C plus 2, can be performed in parallel. So by computing or by splitting this computation across the CPU or GPU, this can give us a significant gain in computational time. And this gain is a very important thing when it comes to big data applications and deep learning applications, especially for complicated neural network architecture, as the architectures we will see in our course, which is the convolutional neural network and recurrent neural network. So this whole idea behind TensorFlow is to have this ability to create this computational graph in code and allow significant performance improvement through parallel operations. So in short, the TensorFlow optimizes its computation based on the graph's connectivity. Again, this is a much more advanced computational graph because I'm calculating a more complex operation which has zx plus x square plus z plus 5. So TensorFlow will create this computational graph in order to execute this function, and the graph looks like the one that is being shown in this figure. Now, in our next video, we will use this TensorFlow framework to build some very basic neural networks.